Good morning, and thank you for joining us for our C-Vision web demonstration. My name is Steve City, John Timmerman. John will be guiding us through the intricacies of the C-Vision floor model, which is sitting in front of us. I'll be going over some of the basics of the line that OGP offers, which is 3 products. One is called the C-Vision Lite. The other one is the C-Vision Benchtop. And then, as we stated here, this is the C-Vision floor model. We're going to put up unfortunately, we only have one model here, but the C-Vision Lite, as you see on your screen, it's a shop floor video contour projector. It's the next generation of what used to be called optical comparators. It is it is a video measuring system. It is made for the shop floor. We have excellent accuracies. We do have the ability to put a 3-lens turret. We can offer a manual stage or motorized. Something that is very nice about this system is it's got something called excellent parfocal, as well as a par-centric. And what that means is that when I change going from lens to lens, if I use the optional 3-lens turret, my part stays in the middle of my screen and my focus is about 1 micron difference. So it's very nice, and it'll be, especially when you have a large field of view system like the C-Vision. Does have a weight capacity of 45 pounds. The next up is the it's very similar to this system that we have here. It is a benchtop version. Little differences, it does have the benchtop has got a little less weight capacity. It is put on a benchtop, and it does not have as large a stage. Just to keep in mind, all these systems are large field of view. So we have a 2-inch field of view with the C-Vision Lite, 3-inch field of view with the benchtop system, and 4-inch field of view with the C-Vision floor model, which again sits in front of us. Both the benchtop and the floor model are motorized stages. They come with a joystick. They have telecentric lenses that are upright and correct. Something that is unique to OGP C-Vision products is a accurate...
Accucentric lens.
Thank you. Accucentric lens that makes sure that we have, when we're switching magnifications, because the 2 models we're talking about, the benchtop and the floor model, have a low and high mag, and to make sure that we keep the same magnification every time we switch back and forth, OGP has got this patented system that they use on their vision systems as well. Right, John?
Correct.
Yeah. So, and then we'll talk about the floor model that does have a weight capacity of 330 pounds. It's heavy duty. We can put some big parts onto this system. Motorized stage, as we talked about. 3 different types of lighting that John's going to go through. And then we'll kind of go into the software. So I'm going to let John start showing us the system. And if you have any questions, feel free to send us a chat, and we'll pick them up as we go. Go ahead, John.
Awesome. All right, guys, like Steve was saying, this is the C-Vision floor model machine. I'm going to kind of go over the outside components of the machine, the lenses, the lighting, all those knobs, the joystick, where all that is at, and then we're going to kind of dive into the software and show you how we'd measure a part, how we'd actually go ahead and set this up for your operators, right? So first thing you're going to notice here in the front panel is this lovely Made in America sticker. That is made in Rochester, New York. Have to show off that when we can. Then we got these lighting knobs here. These can be manually adjusted by you, or, there we go. So if I turn this on, operator can come on here and turn on the light they want. Here's the profile light. Then we also have a surface light, or the coax light as we call it. And these can be modified in the software also, but it's just handy that a lot of people like the mechanical buttons. And then we have this ring light. This ring light is really what I like about this machine a lot, is the benefits of this ring light compared to any of the comparators out there. When you see me swap view here, I'm going to bring you back up to, here's my joystick. So now that you see the part, you can actually see how that ring light works, and it's coming from around the part, which gives us a lot of definition on said part, just like that. If I turn on my backlight, you can't really see that much. It doesn't really show as well. It's coming from this way through the part, giving us the profile of it. And then our coax light, again, is going to be coming from the machine back at the part, and then we see the reflection from there. So that's how everything is working. But this ring light has a lot of benefits that I'll show you right here. I'm going to move this other part into the stage. And this has got some contoured edges to it that make it rather a hard, complex part for, your typical optical comparators. If I were to turn on your normal coax light, you would see something just like that. Maybe. I would even venture to say this is better than what you'd normally see with most optical comparators. It's a lot of good definition on those edges, but that middle centerpiece also has some definition that we just can't see. Now if I turn on my ring light, now you can see the definition of those stars in there and those cutouts. And using our magnification, I can actually use digital mag and slide into that part and see what it looks like.
That's pretty impressive, John.
Thank you, Steve. So now I can go ahead and if I wanted to, I can measure the radii on the tips of these stars. I can measure the contours of the form lines if I wanted to. That's something that can be automatically generated with this system now. So that's kind of the layout of the machine as it lies before. And again, last but not least, going back to my software here, we got the joystick and that moves the whole stage. Moves an X, positive, negative. If I move my Y, feels like Z is the way I'm looking at it here. And that's how you get the field of view there. Now the last thing I want to talk about here is focus, depth of view. One thing you'll notice on this machine here is that there's a large field of view, and that large field of view also gives you a large depth of field. If I go back to this part and I use my profile light.
And while John's doing this, that stage is a 15 by 9 by 2 stage, and again, 330 pounds capacity.
I'm going to zoom out so you can see it at low mag. Actually, I'll use this guy instead. If I turn on my ring light, I'm going to keep that guy in the field of view right there. And you guys can see me. I'm going to pick this guy up, and I'm going to move it forward. She's still in focus. I'm going to move it back. Whoop. Again, she's still in focus. We actually have 2 inches, am I correct, Steve?
Yes, sir.
2 inches of focus here, where it's going to, you can put your part within 2 inches, and it's still going to remain in focus in that depth of field. Makes it very easy, very operator friendly to, did I put the part here? Did I put the part here? Guess what? Either way is going to run just fine, so it's easy to run parts. And that depth of field helps a lot. All right, that's enough about the machine. Let's get into the software, shall we? We've got 3 different software applications that we can work with here, all built into one software that we call SnapX. Swap over that way. All right, we're good. We can see everything. So, most comparators, as you guys are probably used to use. Oh, let me line up that part a little bit better. There we go. We have our standard comparator tools. I can use a crosshair or a standard circle target. Come over here, bring it inside this hole, and it can zero out my X, Y, Z. X or Y, I should say. Boom, boom. X, Y, 0. Let's go measure that hole there. There we go. 1.5. X over there. And we come back and zero it out over there. Crosshairs, circles, box targets, rather simple things that we can run with the optical comparator, but that's nothing really special for this machine. Another thing I will show you quick is an overlay. Since we have this lovely giant TV in the display, we can actually use that to display your guys' CAD files in a manner that is extremely useful. So I'm going to manually orient this part by saying I'm going to zero off on this hole, skew to that hole over there, hit finish, and now my part's going to be lined up. But now I can come over here and align it up to the part with tolerances to say, hey, if this part's fit right within, let's call it 10 thousandths, it has to fit inside these features. So now I can just manually drive around. I'm going to say I'm aligned there. Hit next. It's going to ask me to align over to that other side. There we go. Align that other hole. It's flashing, that way I know which one I need to do as an operator. I hit finish. Now, as you can see, we are aligned to this part. I can drive around and I can establish tolerances. As I turn it on and off, you can see where it should be lying if it's fit properly. We can actually use our magnification. Let's say this little edge right here is a little bit hard to see. Maybe that radius was cut a little early. I can go to my next magnification. I click on this guy, and you're actually going to see the lens change just like that. Now we're using that telecentric lens that Steve was talking about. Knows it goes to the same location every time. And now you can actually see this at very high magnification to see where the part lies and how it's oriented. And we can see any positive material here is not fitting to the CAD model, and thus we can have an issue. This is rather simplistic options that this machine offers that you don't need to use it with, but it's always there if you guys wanted it. What I would rather go to is what we call the Measure tab, because we're using an optical comparator. Let's go measure some items. Software offers the exact same thing we were looking at before. I can use a crosshair target if I want, or I can use a circle target, and I can use that circle target to align to a hole, for instance. I can use my digital mag to zoom right into this guy, drag this guy around until it fits the relative size of my diameter, and I can see down here that my diameter is reading 0.2635. Maybe that's a little bit large. Let's bring that guy down a little bit. Based on what I'm seeing here, I bet you that's supposed to be a 250 diameter, and I'm just a little bit large. Just like that. Now I get 0.2536. If I wanted to write that down somewhere, we could do that. Same thing for crosshair targets, and all of our target icons are all there, just like your standard comparator. But what this guy's better at is actually using Feature Finder, actually letting the software grab everything for you. So I'm going to grab a Feature Finder here and say, I'm going to zoom in so I can see this hole a little bit better. And I want to measure a circle right there. And with ease, I'm able to say, boom, it took, 7 points in the diameter. It measured a 0.1039 hole. I could change the nominal, add some upper and lower tolerances if I want to. I can hit OK and do the exact same thing over here. Click once, 2, and 3. Measure it again. That one's a 0.991 diameter. And then from there, I can say, I'm going to measure the distance between those features. I can see hole 1, diameter 2, and our distance is 1.9971. And if I wanted to, I can enter some nominals and tolerances again and get that data out. So it's very quick and easy for your operators to just come in here and start measuring things with this Feature Finder. We also have the weak edge as well. We can do as a trace tool, a centroid tool. There's many other advanced options to measuring in the software. I will admit we use Feature Finder most of the time because it is so easy. Do you want to measure the top line? Click and drag. It measures a line. I click again. I can do the same thing down here. It measures another line. I hit OK. Come back and say I want to construct the distance on those features. Distance from line to line. That is now 1.4922 inches. There we go. Just like that. We're getting very simple, repeatable data.
So, John, this software, it looks very similar to what's on some of the OGP vision systems.
Yes. So OGP makes Measure Mine, Measure X. This is called SnapX. Measure X, SnapX, very close, we'll call it brother and sister of each other. So SnapX is what we run on our Snap machines. This is the exact same software pulled into a video projector contour machine.
Very nice.
So now, again, ways we can run it with the operators is I'm going to go load up a program that I've already written, but this is how a part should run. So I'm going to open up the show both here so you guys can see what I'm doing as I set this up. So I'm going to hit play, and it's going to tell me to XY0, and I've already written in my directions that I need to use the circle target, and I'm going to align to this feature right here. And again, I can zoom in to see that better, to get more precise if you need to. But since we're using Feature Finder, there is a definite window. We don't have to be extremely precise. It'll do a search function to try and search in that range. And from there, I'm going to do XY0. Last thing I need to do is I need to skew the part. That way it knows if it's oriented at what angle onto the stage. I click on my skew right here. Now that I've aligned it properly, I can hit OK, and it's going to run off and measure this part.
In this part program, you used the DXF file?
I did not use a CAD file.
You did not use a CAD file?
I did not.
Okay.
That will be the next program I run. We do have options of importing 2D CAD files. That's going to be DXF or drawing files. We can then use those nominal geometries as our master that we can compare our measured values back to, and then we can start calculating position, profile, some of the more complex geometry that maybe some of your custom prints are moving towards.
So what you did, John, was just went around and measured this part and created a program.
Correct.
Okay.
It's more of a teach and learn sort of software. I ran all this once. I told it what I wanted to calculate, and you can see here we have 58 dimensions that just ran in the time that we were talking there. What we also did in the background is we're sending this data to a software called QC Calc. There's many SPC analysis softwares out there. This is just one that we work with the most. There's another one called Evolve SPC that is also QVI's product that is also on the system. We just happen to send it out to ProLink at this time. And it's a very nice way of just keeping a history, keeping a database of your parts, seeing what it looks like. And you can track all this without your operators even knowing. So if I hit finish there, I can come back to LOMEG. And what's really nice about this part is I can actually see a lot of features that might not be on my report, or that are on my report, and I can zoom in and see what they look like. Let me zoom around. So here's everything that was measured on this part. It went so fast we probably didn't even see half these dimensions being taken here. If I zoom in, this bolt hole pattern that's in the center has a lot going on. We're taking all these 45-degree measurements between hole to hole, the diameters of each, constructing a bolt hole pattern, also calling out where the XY location of that hole is based on the center hole. So bolt hole pattern to center hole is 0.3 of a thou different.
Wow, that's pretty impressive.
We can see that right there. Let's say I saw a yellow feature over here. That guy right there. Well, why is that guy yellow? I can double click on that feature, and it's automatically going to bring up in my program that I can see the nominal is this, upper and lower tolerance of 2 thou, and we are at almost 2 thou. We're at 1,070 right there, 1,007 So we could see why a feature might have failed, for instance. So that's one way of running it. Now getting back to what Steve was saying, we can run this with measure fit data. That's what we call the importing of CAD files and fitting them back to it. So let me run this part the same way. And when I hit play, I've already set this up once. I haven't moved it yet. So in this case, I can just hit OK, and it's going to run and measure this part automatically. Now, one thing you'll notice is it also didn't have to drive from left to right to run this part. It's actually running faster in this method. And that is one thing that is nice about the snaps and the C-Visions is the large field of view in the digital MEG allows us to keep the part in the center of the screen, and it'll digitally run around the part. So now we imported the CAD file. It looks like that. Imported the dimensions we just measured. And I've added a pause to the system here to allow us time to look at this. And from here, it's a little bright. The bright green is a little bit hard to see. But we can see that we are doing the position of this hole held to AB. Here's datum A in the bottom left hole. B is in the bottom right hole. So we can do position on all these holes. It looks like we added in a 10,000 tolerance there. Position of this, profile of the arc over here. And we can see the positive material is 1/10 30 millionths, and we get 1/3 there, and 0.6 of air, positive, negative material. So if you wanted to, you could automatically dump this to QC Calc, to Smart Profile. In this case, I just add a little stop to say, hey, Mr. Operator, verify the position and profile callouts pass inspection. I hit continue. It bypasses past this. Program is done. It's finished. And again, without anybody even knowing, we actually send all of that measure fit data to QC Calc, and we can see it just like that. So we're tracking our database and our history. So we've been doing a lot of profile light right now, just using the backlight on a very simple part. Let's go back to that complex part and see what that looks like. Let's go to this part right here. I like this one. It looks very, very nice.
See, John just got a text, and their question is that light programmable?
Oh, yes. So let me finish setting this up in the center
Certainly.
here.
Yeah.
So if I were to turn this guy off, especially on a feature like this, let me zoom in once and see what that looks like. So if I turn on the ring light from the center knob as I'm doing down here, you guys can see that it just highlights everything. Well, there might be times where you want to highlight just half the part or half the part on this edge. And we can do that by going to the little dot, dot, dot underneath that ring light here. Click on those options. I'm going to power this on, adjust all of them to be on a little bit. And from here, I can turn on quadrants. Let's highlight half of the ring light. You guys can see that there. Now I can rotate this ring light around the part. And as I do that, you see that the image of that part completely changes and helps me either get better data or maybe worse data if I have it programmed incorrectly. But this is a way to help you get those hard to get features. And if I were to measure a feature with that light there, and then I do a 180 and I now measure a part with that light there, it'll program it in there when we run this. So very handy. You'll see the same style of light on all of the OGP machines, the flashes, the sprints, the quests. And it's very beneficial. It can get a lot of features that might be hard to get. And again, definitely not really something that's in most optical comparators. The ring light's there, but not up to this level.
No, they're not as big either. I mean, it's putting out a lot of light, and it's really illuminating the part very well.
And let's go open a star cube here is my program I made for the star. So again, I'm going to hit play, use my circle target just to align to the one hole here. And I can use my ring light, backlight, profile light, whatever one we want. I use my backlight for this one. And again, XY0. Now, I'm not going to skew this part because I'm going to assume that because it's on the stage, we're level enough that we're going to be able to know how to measure this part. So I'm going to hit OK. Now it tells me, hey, in case you didn't already do this, align to the top left hole. So I'm going to say, OK, I have done that. I'm going to take a point by clicking Enter Point in the software here. And now you're going to see that ring light. Half of it's turned on right now. I'm going to shift over. Let me see if I can't zoom into that part for you guys. There you go. So you can see all the different geometries being measured here just by different lights being used. And I'm using that ring light to get those center. I'm not really sure if I'd call them center. The bend lines I could get with the coax light, but now I'm able to actually measure the edge where it was cut with that ring light. Again, change magnification to zoom into this part. Driving up into the location it needs to measure the radius. Took that radius. Now it's just going to go measure the tips of those stars at high meg to try and get the radius that was measured out of that. And now let's see it. You can actually see the machine moving more than you see the image move in the model window there. But again, that is the power of the ring light. And if you notice, I am at stage 4 of my zoom when I have 2 more options. So I could go even further like that. See that magnification? And one thing I didn't show you guys, let me go back to my setup here, my webcam. The one thing that is not automatically controlled is going to be the focus here, using this knob to pull the stage away from the camera, use this to get it closer to the camera. So what I can do is I can finesse that edge just like that. Go back to the software. Now I can see that edge looks nice and defined. If I hit finish, let me just do an extra feature finder on the guy to see what that radius is. High meg. Say 100,000th radius right there. So, yep. Want to make sure I wasn't as a diameter. So, there you go. Rather small features, things we can measure, I want to say relatively easily, but you know, that's all relative. And then we send all this data again to QC Calc or any of your SPC analysis software. And here's all my star cube data that I've been saving. And that is the benefits of the C-Vision. Steve, is there anything else that we want to cover in this bad boy?
Well, no, but I just want to make a point that, you know, we were talking about the large capacity of the machine, but yet you were measuring very small features very easily. And that's a very impressive lighting system on this system. And it's, like I said, we talked about it is on the, not only on the floor model, but also the benchtop. And the C-Vision light does have a little bit different illumination, but it does still have a very nice large field of view. So, I don't know, let's see, do we have any other questions from anyone on the line, or?
Let me switch over to chat real quick.
Okay.
The weight on the table, that was 250 pounds for this guy.
No, 330 pounds.
Oh, never mind. Sorry.
Okay.
That's higher than that. I thought I was being nice at 250 pounds.
Yeah.
And it does scale up. The C-Vision light was 45 pounds.
Yes.
And then it looks like the C-Vision benchtop is 60. And then we jump up to a stage like this, the C-Vision floor model, that can hold 250 pounds on this guy right here driving back and forth. Another thing they talk about with comparatives is how much room do you have in between this envelope here, right? We actually have 16 inches between the front lens and the back lens. So you could have a part that is 16 inches wide come in here. Now our depth of field, again, is we only get 4 inches of travel. So you have to measure something right in 4 inches of that 16 inches. But you could put a part in there and still measure most of it, hopefully by all means.
Okay. Well, anything else you'd like to cover, John?
I believe that is it.
Okay.
Yeah, I apologize if I missed anything else, guys, but just want to give you guys a quick overview of the machine we have in our office here. If anybody wants to come in and see the machine, we will have it for the next, I hope, maybe a week or two.
Mm-hmm.
And then we might have to send it back to either Arizona or New York. QVI wants it back. Apparently they're a hot commodity. Maybe it's because they're so good. Who knows?
Okay.
But it looks awesome.
Well, great. Well, we appreciate your time today. I know everyone's busy, but take a little time and see some of the latest and greatest products from OGP and the C-Vision video contour projectors. Again, thank you very much, and feel free to email me or John if you want any, would like to come in and have a personalized demo. Thanks much.
Thanks, guys. Take care.
Thanks.